everybody. Welcome back to Psychedelics Today. This is Joe Moore coming at you from Breckenridge, Colorado. Beautiful summer weather here. Can't believe it's already halfway over. So today on the show, we have a guest that many of you will know, some of you will not know, but one of the most exciting interviews I got to do. He's certainly a hero of mine. Dr. David Nichols, PhD chemist. I'm going to read a bit from his Wikipedia page here. It's pretty substantial. And before I do that, he was the gentleman who made a ton of MDMA for the MAP studies. And I believe he's also made a number of other psychedelic compounds for the research projects going on out there. So here is David Earl Nichols is an American pharmacologist and medicinal chemist, previously the Robert C. and Charlotte P. Anderson Distinguished Chair in Pharmacology at Purdue. Nichols has worked in the field of psychoactive drugs since 1969. While still a graduate student, he patented a method that is used to make optical isomers of hallucinogenic amphetamines. His contributions include the synthesis and reporting of escalene, LSZ, 6-APB, 2CI, NBOME, NBOME, and other NBOME variants, NBOME-2C-B, NBOME-2CC and D, and several others. And he also coined the term entactogen. He is the founding president of Heffter Research Institute, named after German chemist and pharmacologist Arthur Heffter. We get into a little bit of Heffter's biography on the podcast. He is the guy that kind of discovered mescaline in peyote. And maybe I'll wrap there. So David Nichols is an amazing chemist, and I think a really important figure in psychedelic history and psychedelics today. So really happy to have him here. And yes, thank you, David Nichols. It was really wonderful having you, and I hope to bump into you in the future. And actually, he's, I believe, the keynote speaker at the Telluride Mushroom Festival in Telluride, Colorado this summer, and I was able to score some press passes and can't wait. I'll be there. If any of you are going to be there, let me know. You can just reach out at Psychedelics Today, email at Gmail, and hope to see you there if you're going to be there. And if you want to support the show, just leave a review. Let your friends know about how amazing. if you like the podcast episodes, let your friends know. And that's it. Thank you very much, and see you on the other side. Hello, everybody. Welcome back to Psychedelics Today. Today on the show, we have a great treat. We have David Nichols, PhD, quite famous figure in the psychedelic world. Thanks for joining us.
Yeah, my pleasure.
So today, we want to kind of talk about you, your background, and Heffter Research. What's the full title of Heffter? Heffter Research Institute?
Heffter Research Institute, yes.
Yeah, cool. So I actually don't know too much about your backstory other than that you synthesized a whole bunch of MDMA for MAPS. How did you first get interested in chemistry? Was there a certain point when you...
Well, when I was a kid, I made pyrotechnics. Rockets and little bombs and things like that, which classically, that was the way many chemists got interested in chemistry, by making things blow up and smoke bombs and whatever. So I was always interested in that. At one point, I was going to become a doctor, MD, and then I found out somebody told me you had to know Latin. And when I took Latin, I hated Latin. I said, well, if I have to take Latin to be a doctor, that's it. So then I looked for something else and basically just focused on science. And then chemistry, biology.
Oh, that's great. Did you, in your undergrad or graduate years, is that when you started bumping into psychedelics?
Yeah, really, probably a bit before I went to graduate school. Mm-hmm. I got interested. I lived at home and commuted to the University of Cincinnati, but a lot of my friends had gone off to school, and they came back in the summer of 65, 66, talking about LSD and marijuana and mescaline and peyote, things like that. I didn't know anything about them. And I thought they were all going to get addicted. And so I was telling them, you guys are messing around. You're going to screw yourselves up, get addicted to these things. And they just kind of laughed at me. So I went over and bought a used book on pharmacology and read about marijuana and some of these other things. And I thought, this doesn't fit with what we've been told. So I was very curious as to why that was. So I got interested in what they actually were and how they worked. So I was kind of the local guru for the people that were using these things. They'd ask me a question and I'd look it up and say, yeah, this is what it is. This is how it works.
Mm. Is this around 75 or so? Or
I know, 60, 66, probably 67. I started graduate school in 1969, and my project in the graduate school was to work on mescaline analogs. So, and I continuously worked in the psychedelics from 69 until really kind of to the present. So I was in it for a long time.
Yeah. That's many decades. Now, did you slow down your research when the federal government kind of stepped in, or were you able to say, I'm doing something different?
No, people asked me that. I never really had a problem because I wasn't doing clinical studies. We were doing chemistry, and at one point we were using cats, and then we were using mice, and then we were using rats, and we had smooth muscle tissues. So because I did a postdoc in pharmacology before I went to Purdue, I had the medicinal chemistry background from Purdue, but then I also had a pharmacology background. I did a postdoctoral fellowship. So I combined chemistry and pharmacology because there was nobody that was interested in the pharmacology of these. If I'd been working on drugs to treat HIV or anti-cancer drugs or whatever, I could have sent my compounds to some company and they would have screened them for me. But I had to do all the screening myself. So we bootstrapped up all the basic pharmacology assays that anybody would need. And then I just had students, I'd come in and say, here's the assay, let's get this worked up and run it. So we'd start doing it. It was kind of funny because I had a grant for about 10 years to study MDMA, and I proposed to use a procedure called in vivo microdialysis. You put a small microdialysis probe into the brain of a rat, and you can measure perfused artificial cerebrospinal fluid through, and you can measure what comes out. And so I wanted to look at serotonin, dopamine, norepinephrine coming out of the brains of these rats after they'd been given MDMA. And I wanted to put probes in different parts of the brain and see what was going on in each of these parts of the brain. And I sent a grant in, and one of the reviewers said, the principal investigator fails to appreciate the difficulty in implementing in vivo microdialysis. And we had already published a couple of papers. We had all the equipment. I had people doing it. Really kind of pissed me off. And what happened was one of the reviewers, I looked at who the reviewers were, and one of the reviewers in Bread and Butter was doing in vivo microdialysis. So he probably thought it was pretty arrogant of me to think that I could just use a technique that he had devoted his life to. That's pretty much what we did with all the pharmacology assays. They aren't that difficult in most cases to set up. You just have to want to do it. You have to understand something about how they work and have the right equipment. But so we did a lot of pharmacology too.
Can you give us like a really rough sketch of what an assay looks like? You were mentioning animal models with soft tissue earlier, but
you cut off a piece of the rat's stomach is in two parts, and it has a muscular part which crushes the food that they eat. You cut that out and cut it into long strips. And you put a thread on each end, and you tie one end down inside an organ bath, a glass bath that's got artificial cerebrospinal fluid in it. And then the other end you hook to a force displacement transducer. So when it pulls, you hook it up to a recorder and can tell you how much force there is. So what you would do is just take a syringe and squirt in a certain amount of drug, and you'd look at how much the tissue contracted. And then you'd squirt in some more and see how much more. So you could do what are called cumulative dose response curves by adding increasing amounts of drug into the bath and looking at how the tissue contracted. And you can plot a dose response curve and measure the ED50 and things like that. Animal assays, basically mouse head twitch or mouse ear scratch, were assays literally that just where the mouse scratched his ears or twitched to say their response to a psychedelic. We used, for most of our behavioral assays, we used a thing called two-lever drug discrimination with rats. And that's the case where you have an operant chamber, a box with two levers in the front. And the rats trained to associate one lever with a drug like LSD, and the other lever associates with placebo. And so after you train the rats to press the lever, you give them injection of LSD, they'll go into that box and they'll just press the lever that's associated with the LSD. And so once the rats are trained, we develop analogs. We have analogs of LSD. And we'd say, well, is this like LSD? And we couldn't test them in humans. So we'd inject them in these rats that were trained to recognize LSD. And if they responded on the LSD appropriate level, they basically were telling us, I think you need the LSD. And so that was the best we could do. And obviously, clinical tests were not available, but that was actually a pretty good assay. And the potency of drugs in that assay generally correlated with potency in humans.
Did you find a mescaline analog that was most interesting in the lab?
Well, most of the mescaline analogs we made were actually more potent than mescaline. And then when we got into amphetamines, we worked with things like DOM and DOB. And Shulgin and I made DOB at about the same time. I was a graduate student, and he made it in his lab. And he sort of talked about it. He'd given it to humans, and we were putting it in smooth muscle assays. But what we started doing was mescaline is a real floppy molecule. The side chain twists around, methoxy groups twist around. So what we did is we would lock them into particular conformations or shapes. So if the side chain could just flip around, we'd take a couple carbon atoms and tie it back into the ring, and we'd lock it to a shape. So we do things like that, trying to figure out what shape did the mescaline molecule have when it bound to its receptor. So we mapped that out for quite a few molecules. All the psychedelic amphetamines, we mapped out what the orientation of their methoxy groups was, and just basically basic science stuff like that. Then, of course, we published it, and people started following our literature and started making them into these so-called designer drugs. So that was kind of an unhappy circumstance at a couple of points.
I think in the Shulgin documentary, they talked about how the black market somehow was able to get some of his formulations before he even published somehow, which is, I don't know if that's true.
Yeah, I don't know if that's true or not. There was this compound called STP that hit the streets in Haight-Ashbury, I think in 1967. A bunch of people overdosed on it. And actually, Sasha developed that when he was working at Dow Chemical Company. And he always denied any knowledge of how it got out. But Tim Scully sent me an email from Owsley, where Owsley said Sasha came up to his house one day and gave him a 25-gram bottle of STP. It was about the time LSD was being made illegal, and Sasha told him, well, maybe you can use this to replace LSD. That was kind of a revelation. This is after Sasha had passed away. I found this out, so I had never known that. So maybe Sasha feigned ignorance on some things where he actually knew more than he was willing to talk about.
That smile. I'm sure a lot of us are going to be taking stories to the grave with us because there's so much that we don't necessarily want to share. But, who knows? So can you talk a little bit about how MAPS kind of engaged with you way back to make a very large quantity of MDMA? Was it a kilogram?
Yeah, 2 kilograms. So I was invited to a meeting at the Esalen Institute on the West Coast. And they were all the kind of luminaries in the field were there. Anybody who had done any work with psychedelics was there in the fall of 1984. And again in the spring of 85. And I met Rick Dobbin. He was a young kid in New College in Florida. And he was very enthusiastic about MDMA and marijuana and all kinds of things. And I had a long talk with him and said, he was going to change the world. And I said, well, you're not going to change the world unless you get a PhD and get credentials. But anyway, he knew sort of what I was doing. And at a certain point, he had decided after he got out of New College, he wanted to develop MDMA as a drug. And to do that, you needed to do preclinical toxicology to give it to animals, usually 2 species, rats and dogs. You give them big doses, and then you sacrifice them and slice them up, and you examine every part to make sure to see if there's been any damage from the drug. And he needed some fairly pure MDMA to do those studies. So he asked me if I could do that. I said, sure, it's a simple molecule to make. So we made 2 kilograms for, I think it would cost $4,000 in starting materials. And we made it to a high degree of purity. It's 99.98%, something like that. He only needed 250 grams for his preclinical tox, so we had another, a kilo and a half in the safe for years. I routinely donated to anybody who had a license and was going to do legitimate work with it. And then when I retired from Purdue, I transferred it all what I had left to him. So that was the first thing. It was all the early studies that were done with MDMA that MAPS funded, and also most of what other people did were all done with that MDMA that I made at Purdue. So it really served as a foundation. Had I not done that, he couldn't find anybody to make it in the way that he could afford. So had I not done that, probably MAPS would have been a lot slower in getting their work done, if at all. I mean, that's a real obstacle when you say, well, I need, a kilogram of this stuff and nobody will make it for me. And then it was scheduled. It wasn't scheduled when I first made it, but then they made it Schedule 1 after that. So that would have made it even more difficult. So then I met Rick Strassman also at Esalen, and he got ready to do a study with DMT. And he said to me, well, if I go through all the hassle of doing all the paperwork and getting all the approvals, but then I can't find anybody to make the DMT, I'm stuck. And could you do it? And I had just made all that MDMA for Rick Dobbin. So I said, sure, I can do it. So that's what happened. Nobody would make it. So then I made the DMT for his study, which, he did DMT, the spirit molecule, the movie and the book and the whole bit. And then when they started using psilocybin at Hopkins, I made the first batch of psilocybin for the 2006 study that Roland Griffiths and his colleagues published, where they gave psilocybin to normal, healthy individuals. And then they used that for their big study that they published with psilocybin treatment of end-of-life distress. So actually, I produced a lot of the molecules that allowed the field to move forward. Probably no one was willing to do it, and me being at Purdue, it seemed like a fairly safe place to be in the middle of the Bible Belt. Yeah.
Well,
plus, I really wanted to see these things eventually get into the clinic. I've been convinced for a long time that all the early anecdotal reports had some truth in them at least, and these things really need to be investigated.
Is your primary interest around beyond chemistry, for psychedelics coming into the world around medicine, or perhaps creativity, or what? How does that strike you or work for you?
My belief is that the only way these would ever become available would be to use the medical model. Mm-hmm. A lot of people don't believe in that. They say, why should doctors be the ones that have it? But that's the way our society is structured. Now, whether these things eventually, maybe 50 or 60 years in the future, they won't be as controlled, society will change, cooler heads will prevail. Okay, so, but I thought going through the medical model, getting approval, getting them developed as medicines, that was the way to go. And then what happened after that, it would be anybody's guess. But at least getting them approved for use by qualified therapists. So the medical model basically is what I followed. I haven't seen strong evidence, strong conclusive evidence that they stimulate creativity or, all these other things that people say. They may, but I said, I'm going to focus on getting these out to doctors and to the FDA and getting them approved. And some people argue about that, but it's worked so far.
So you've had some interesting things to say about microdosing. I was wondering if you could give us just a little brief critique.
Well, I haven't seen any really definitive studies that show that microdosing works. There's this thing called the placebo effect. And when you do a clinical study, the placebo effect can be really strong. So in drugs that have a CNS effect affecting the brain, you can get a really powerful placebo effect. Pain-killing effects from the sugar pill that are really pretty amazing. So these people that are taking 10 micrograms, 15, 20 micrograms, the questions I have are, first of all, how pure is the substance they're taking? How accurate is the dose they're taking? And how much of this placebo effect? And that may well be that at low doses they can have some effect. But I haven't seen any conclusive evidence. I'd like to see double-blind, placebo-controlled study where they used 10 or 20 micrograms in a control group and measured some aspect of cognitive functions that indeed these things do. There are kind of hints of it in some studies that have appeared recently, but I haven't seen anything that I would say is really conclusive. So, Amanda Fielding wanted to do a big study of microdosing and get a bunch of money. It would be really expensive. And I just thought, that's kind of a waste of money. If you don't know it's going to work, it's hard to get money from philanthropists. So fundraising is a big, big challenge for any of these not-for-profit like Heffter or Amanda Fielding's and the Beckley. Fundraising is a real hassle. So I just couldn't see spending money on something like that when we had things like eating disorders, obsessive compulsive disorder, and things where we knew we might have an effect and where there was an unmet medical need and lots of people that were suffering. I thought that makes a lot more sense than spending money trying to develop something like that and trying to see whether people could microdose. And even if microdosing worked, even if it did work to do something useful, I'm not sure you would ever get approval to market it as a drug, because if you had tablets of 10 or 15 micrograms of LSD, the FDA is not going to let a pharmacist prescribe a bottle of those to you. You just take 10 of them and you get a full dose. So there are just a lot of issues I have with it. I mean, it's a popular meme, and Jim Fadiman and other people, oh, this is really interesting, and can do this and that. But I think it's just kind of a lot of hype. That's just my personal opinion.
And, that's a fairly reasonable place to land. You probably saw Dr. Twiston Passey's new book, The Science of Microdosing Psychedelics.
Yeah, I was I edited that quite a bit.
Cool. So, this consensus is still out in a large part. And I like your logic there. If we know that we can end a lot of suffering, why wouldn't we? Through these other means. Yeah.
And I'm not sure if microdosing works to stimulate, imagination or just like a psychostimulant. There are legal prescription psychostimulants, Provigil or, Ritalin, things like that people use, ADHD drugs, that might do the same thing in their prescription. It's the mystique of a psychedelic, I think, that kind of makes it different.
Right. I've still not even tried it. So that's where I stand. Another interesting thing that you've commented on is this hypothesis Strassman put out about pineal DMT and this whole tripping thing. Can you kind of give us a short little rundown on that critique?
Well, his hypothesis was that, during birth and at end of life, the pineal gland produces a DMT, which produces an out-of-body kind of a psychedelic experience. And the problem with that idea is that the pineal gland is really too small. It's 180 milligrams, less than 0.2 of a gram. And its sole function, as far as we know, is to produce melatonin. And over 24 hours, I think it produces somewhere around 25 or 30 micrograms in a 24-hour period of melatonin. So Strassman and Andrew Gallimore basically came up with an experiment that you could keep somebody in that DMT state so they could communicate with aliens. And so there's a paper that came out and said, okay, what you need is to get the plasma concentration of DMT to this particular level. You do it initially with an intravenous, I think, intravenous injection of 25 milligrams. And then they reported what the plasma level would be based on the Strassman studies. Well, the pineal gland can't produce 25 milligrams. It produces 25 micrograms of melatonin in 24 hours. So how is it going to produce 25 milligrams of DMT? So that's the basic problem. You've got this little tiny organ that we pretty much know what it does. It doesn't really have much machinery for making, substantial amounts of DMT, and huge amounts compared with what it normally produces. So I just said, this doesn't make any sense. If you want to talk about people having psychedelic experiences in times of crisis or stress, it's more logical to look at some of the endogenous opioid type compounds, endorphins, things like that, which, like the runner's high. People talk about the runner's high being producing endorphins, and so they get the second wind is high that makes them feel euphoric, etc. Those are endogenous compounds that are produced, but they're not DMT. They have nothing to do with DMT. So if you want to look for something that produces these effects, then something like that is more reasonable to look at than the impossibly large amounts of DMT that the pineal gland would have to produce. Yeah, I gave that talk first at the Breaking Convention a couple of years ago. And when they called me and emailed me and said they wanted me to give a talk about the pineal gland producing DMT as a neurotransmitter, I said, well, you don't want me because I don't believe that. And they wrote back and said, yeah, we want you because you don't believe it. We want somebody there that takes the opposite point of view. So I gored some oxes there. But there were also a bunch of people that came up and said, that's really cool. You need to publish that. So I actually published a paper in Journal of Psychoactive Drugs where it was all kind of summarized. So I don't know I think the diehards probably still hold on to it. And I see once in a while they refer to me. And when Nichols has said, this can't happen. And so there's still debate. But from a science point of view, it just didn't make sense to me. And if somebody can prove it, that's fine. I don't have a problem if somebody can. You get somebody who's dying and you measure the plasma concentration, it's loaded with DMT, and you go, oh, wow, I don't know where that came from, but, I'm perfectly willing to accept it, but there just hasn't been any experiment that would be reasonable.
Yeah, cool. Well, thank you for that. Yeah, it's an interesting meme that I have to deal with because I'm in the media space, and people say, Strassman proved this. I was like, wow, no, not at all. That's a very different thing from what he talked about.
Exactly.
Yeah. Okay. So thank you for that. Now let's, before we get into Heffter, is there anything in your history you want to throw in?
No, not really. I mean, it's just like I was lucky to be in the right place at the right time with the right interest. And, when I went to grad school, I went to work for a guy that I didn't expect to work for, and I went there because he hadn't published anything. And he didn't know as much about the field as I did, and he just basically gave me carte blanche to do whatever I wanted. And that doesn't happen very often. And then when I left and went to Purdue, then I did a postdoc at Iowa Medical School. When I went to Purdue, I was fortunate. They were looking for somebody they could bridge both chemistry and pharmacology. So it was lucky I got that position. And then, I got grant funding from National Institute of Drug Abuse to fund my work, at least half of it. So I consider myself very lucky. I know a lot of people that wanted to be the so-called psychedelic chemists and just, never got there, never had the opportunity. Well, there weren't many opportunities. So I say I was pretty lucky.
Are you still, given our current geopolitical situation, financial debt crisis in the United States, would you still be comfortable suggesting people go the PhD route if they want to really make big change? Or where do you stand these days?
I have recommended some people do that. I had a fellow who had experience with a psychedelic, a young chemical engineer who came to my office a couple of years ago. And he wanted to know, he decided to go into medicine after he had this really intense psychedelic experience. And he said, is there any chance I'll be able to do research in this field at all, work with these at all? And this was a couple of years ago. I said, you have 4 years of medical school, 2 or 3 years of residency. That's like 7 years, maybe a little bit more. 7 years from now, I said, things are happening so that it's quite possible that within 7 years, you may be able to find a place, because I think this field is going to open up. We need a couple more studies to be published, validating the fact that psilocybin is useful in treating addiction and depression. Some of those studies are underway as we speak. A couple more of those studies, and the NIH and NIMH, there are hints that they're kind of getting very interested in this field now too. So if it really blows up like it could, then there may be a lot of funding. Maybe a lot of people looking for this kind of research. So he was really pleased. I said, if he'd come in five years ago, I would have said, forget it. But I said, things look bright on the horizon at this time. Right. Could be brighter, but I never expected to be alive when all this was happening. Somebody asked me once what I thought the future would be, and this was years ago, and I said, Yeah, someday, probably long after I'm dead, somebody will be having a midlife crisis, and their doctor will send them down the street to a psychiatrist / shaman who will give them a psychedelic session and help them get a perspective on things. This woman said to me, "Oh my gosh, you think to be dead? That's so depressing." I said, "Well, if the trajectory is going in the right direction, I mean, I might not be here to see it, but if it's going in that direction, it'll be satisfying." So I never really thought we'd get as far as we have. Things have just really surprisingly opened up quite a bit, and some really good, dedicated people have got in the field and done some research. And if that keeps on, scientists are always looking for new fields to, cut their teeth on and places to get grants. And there hasn't been any grant money. If there's grant money available to academics will be attracted to this field. None of the federal agencies have funded this so far. But they discovered back in 2000 that ketamine had very rapid antidepressant effects. Now that's all the rage in all the scientific circles and National Institute of Mental Health. Oh, we got to find out how ketamine works. Well, it doesn't work nearly as well as psilocybin works from what we can tell with the studies that we've done. But because ketamine is legal, it's not Schedule 1, everybody got all excited about it. Well, I think they should get just more excited about psilocybin. We just need a few more studies to convince the diehards.
Right. There's a lot of reason to be optimistic about careers in this field, given, MAPS and both Compass having phase 3 fast track with the FDA. And
yeah.
I'm sure there's going to be some similar stuff in Europe coming pretty soon. And I wouldn't be surprised if plenty of other countries open up in the near future.
Yeah, I think places in Europe will be opening up too. There are some places that are pretty tight. Germany's, they're not very good about this, but Czech Republic and Portugal and some places like that are pretty open to this.
Mm-hmm. Yeah, absolutely. Okay, so let's talk about Heffter. How were you involved at the founding of Heffter?
Yeah, it was my idea.
Cool. So how did that play out? You had this idea and you got some contacts?
Well, I was doing basic science on psychedelics, animal models and receptor studies and so forth. But, when you give LSD to a rat and he presses a lever, or you give an LSD analog to a rat and he presses a lever, he's telling you, I think you need LSD. That's really a pale reflection of what happens in humans. How is it even relevant? I mean, it's a model and you can potency, but so I was doing all these studies for years and I was going, my God, somebody should be doing clinical studies. I didn't have an MD, so I couldn't do them. I needed to be a physician to do it. So at a certain point, and I'd go to these meetings and I'd talk to people from the 60s that had gone through the psychedelic phase and they thought somebody should be doing research and gosh, why is nobody studying these? These are such interesting compounds. And we'd both be bemoaning the fact that nobody was doing the research, the clinical aspects of these, and wasn't it awful? And then I'd go home. And there was one point where I went home after one of these meetings, after I'd had a discussion with a colleague after a meeting, and I was sitting at home and I thought, you're going to be telling that same damn story when you're 80 years old sitting in the rocking chair. And you need to do something. And so I just basically said, well, I don't have an MD, but I know a lot of people who do have MDs who might be interested. So I called half a dozen colleagues and I said, why don't we start? And I had told people for a long time that the only reason you couldn't do research was because there was no funding. And if you could get philanthropy funded, you could do it. I said, let's start this thing and see if we can't find some philanthropists. And in the beginning, we thought there were a lot of people in Silicon Valley who would fund this work. And we were badly mistaken about that. But that's what we thought in the beginning. So we just started with that concept of let's find philanthropists and let's go back and fund some studies and see if we can validate some of these old anecdotal reports. So that was 1993 that we were officially incorporated. But I'd been thinking about it for a long time and just finally decided, to get off my ass and do something. Even if I couldn't be the clinician, I knew people who probably would be willing to do it. And of course, there were lots of people who wanted to do it. They just said, yeah, get us some money.
Yeah, that's really great. So who were some of the people you had involved closely when you launched in 93?
Well, Charlie Grobe, who was at UCLA, Rick Strassman initially was involved with us, but then he dropped out because he wanted the Heffter to be more about sort of celebrating his work. And that wasn't my idea. So he dropped out. Then George Greer, who was a physician, he's still the president. So he was the head of, I think, the corrections, medical department in New Mexico corrections and jails. He was interested. Mark Geyer is a PhD, really good behavioral pharmacologist. Phil Wilson for a little while, and then he dropped out because he thought that he knew a bunch of people that would fund us in, and that didn't happen. So he just dropped off the side for their money. So I'm going to drop off of here. So basically, it was just a small group of mix of MDs and PhDs we started out with. And then we've added a few people, Franz Vollenweider, and mostly the rest of them have been philanthropists who brought money to the table.
Oh, that's great. Now, I guess let's start with Heffter. Heffter was a German chemist, is that right?
Yeah, it was funny. I was at a reception where Ralph Metzner was in California, and I was talking about the Heffter Institute, and he said, "Dave, who was Arthur Heffter?" And I said, "Ralph, I can't believe you're asking me that question." Arthur Heffter was a turn-of-the-century scientist. He had a PhD in pharmacology, PhD in chemistry, an MD degree. He was, at the time, in the late 1890s, he was probably one of the most well-respected scientists in Germany. He eventually became the dean of the medical school at Berlin, Germany, that was the top medical position in the whole of the German Empire. So he got samples of peyote from Park Davis. And there was another guy, Louis Levine, who was a toxicologist. Louis Levine was a toxicologist, but he didn't have an academic appointment. He just had his own little lab, so he didn't have money, he didn't have sponsors, etc. He had played around with peyote for a while, and he knew there were alkaloids in there, and he thought in the mixtures of alkaloids were probably what was made peyote active, but he wasn't able to separate them. Well, Heffter, having much greater expertise, having a big lab full of people, he separated all the different components in the peyote cactus, isolated them, and he took one dose of peyote, and isolated all the alkaloids, so he knew that each one of those alkaloids would have been one dose. And then he took each one himself to see what happened. And so he's the one who discovered that mescaline was the active component in peyote. And mescaline wasn't synthesized until 1919 by Ernst Speth. So he was the first guy. He did a lot of stuff. He was the guy who invented hair tests. There were people that were suffering from lead poisoning, also arsenic poisoning. He discovered hair tests that you could take hair and you could identify they had arsenic. He was a public health expert. The Germans were putting lead liners in their beer caps, and the lead was leaching into the beer, and they're getting lead poisoning. And he testified and said, "You got to take the lead out of these caps." He was an expert. He was called to testify all over because if you wanted to know something related to public health, this guy had a PhD in pharmacology, PhD in chemistry, was an MD. He covered the whole breadth of things. So I thought he was a perfect person to name the institute after because he had done careful self-experiments and had identified this and was sort of a public health expert and really highly regarded. And we have some stuff that's on the Heffter website that talks about him. I think we still have a whole biography there of him. He was a remarkable guy who was very much underappreciated. But he was doing these things. He was doing, testing mescaline on himself before Albert Hofmann was testing LSD, back in the 40s. So he was 50 years ahead of Albert Hofmann.
Well, that's fascinating. Yeah, I believe more people should know about him. Is there a good biography on Heffter?
The best biography is probably posted on our website.
All right.
We have some photographs of him in his lab, and we had a photograph of him and his wife Elsie, and there isn't a lot about him because he wasn't that much appreciated. And he was unique. If you read the biography, they had a celebration of his life like 50 years after he had died or whatever. And his students said, we'll never know how much he really did, because a lot of times he'd come into the lab and he'd tell one of his students or assistants, you should do this. Okay, that's something pretty. And they'd do it. And then they would write it up for publication. They'd bring it in, and his name would be on there. And he'd say, I didn't do this work. What's my name on there for? But it was your idea. No, you did all the work. And you take my name off of there. And that was very unusual, because in Germany, usually you had one guy who was the top guy in the lab, and he had all these assistants that worked for him. And everything that was done bore the top guy's name. And the Germans were pretty OCD about that kind of respect, or whatever you call it. And he was just completely different. He was just an easy, laid-back, easy-going guy who said, you did the work. Don't worry about me. He was a lover. His PhD thesis was dedicated to one of the composers. I forget which one now, but I mean, really a Renaissance kind of guy. All his offspring ended up married to really high-functioning people. I think one of his daughters was married to Geiger, the guy who developed the Geiger counter.
Wow.
So they had family reunions one year, and I got a note from one of his great-great-granddaughters saying, we have a Heffter reunion every year, and there's 30 or 40 of them. And 75% of them have PhDs and MDs, and they're really high-functioning. So he was really an inspiration to the whole family.
Yeah, well, that's really cool. So, about Heffter Research Institute, I guess over the last, since 93, what for you has been the most exciting thing out of the organization or set of things?
Well, the first thing that we published that really made any splash at all was Charlie Grove's study of psilocybin in terminal cancer patients. A small study, underpowered, didn't catch a lot of attention. But when we did that study, we knew that LSD had been used to treat dying patients, cancer patients, back in the 60s and early 70s. But we didn't know whether psilocybin would work the same way. I mean, they're both psychedelics, but LSD is kind of a different beast, LSD is an elephant, and psilocybin is a wolf or a dog or some little thing. I mean, we didn't know if that would work. So the fact that we got that signal was really good. And then, the big studies, two of them were published out of New York University and Johns Hopkins in December 2016. We really got a lot of press coverage and got people really excited, where we showed that the psilocybin treatment of anaphylactic stress had tremendous, powerful effects. And nobody had expected the magnitude of the effect. So that was really amazing. And the fact that psilocybin has turned out to be kind of almost a wonder drug. I mean, it seems to be used for treating addiction, anxiety. And we have a study that started at Yale treating obsessive compulsive disorder. We've expanded the study of alcohol use disorder at New York University. Michael Bowman did the small pilot study with, I think, 10 subjects in New Mexico. He's now got a study with 100 subjects, and it should be done sometime this year. We'll see, but the results so far look good. We've got a small study of psilocybin assisted therapy and cocaine addiction at the University of Alabama. The nicotine, the smoking study, that's been expanded by Matt Johnson from the original smaller study. And these things are all looking pretty good. So, we selected psilocybin deliberately. We sat around and said, what drug should we use? And we thought, well, if we use LSD, there's going to be a media feeding frenzy. Everything we do, we're giving LSD to dying patients, we're giving LSD to alcoholics, whatever. And even though that had been sort of what had happened in the past, we thought this is really going to call in the dogs on us. So what else could we use? Well, DMT you'd have to inject, and that's short acting. Mescaline, it's long acting, but it makes people feel nauseous, and sometimes they actually vomit. So, and long acting, LSD was also long acting. So anything long acting, that the clinical time would be increased because you'd have to keep them overnight to the next day rather than being able to just discharge them. So we looked at things and we said, let's go with psilocybin. We didn't know whether it would work as well as LSD, but it was shorter acting, which meant we could have one clinical day, would be less expensive. It was fairly non-toxic. As far as we knew, it had a history of use. I don't know how many people have used psilocybin mushrooms, but 30 million people use LSD, so it's got a record of safety. So, but the South American Indians used it. There was no you didn't hear about people dying from eating psychedelic mushrooms. So that was a fortunate choice, I think. And now everybody is really focused more on psilocybin than anything else. And we deliberately chose psilocybin for the studies that the Hefters did. And then I've done some work on the chemistry to improve the synthesis of psilocybin. Hoffman's original synthesis used a substance that was pretty dangerous. And if you had the pure substance, it could just spontaneously detonate, explode. And so we found, kind of a better way to do it that didn't involve such dangerous reagents. So it made it a lot safer to make psilocybin. Now the method has been improved a couple of times by some other people, but basically, psilocybin that's probably the remarkable thing that we just had no expectation would work as well as it does. And it's affordable and relatively easily made.
Yeah, it's really interesting. And I think that is the logical choice, right? Like you could have something perhaps that only works for an hour, like a salvia or something, but it's kind of a weird drug. But psilocybin just seems to fit the bill time-wise. And
yeah, I think so. A lot of people are interested in 5-methoxy-DMT. That's a really powerful psychedelic, but it's short-acting. And the problem with short-acting, if you get into a state, if you work into it like LSD, it takes an hour or two. Or psilocybin, it takes a while before you get into whatever that mental state is. And then after it wears off, it slowly wears off, and you've got time to integrate and talk about what happened. Something like 5-methoxy-DMT, it just like blows you out of a cannon. And then you don't really have any time to prepare for it. And then afterwards, integration time. I know there's interest in seeing that develop. People are talking about using, toad. You've heard of the toad venom, smoking toad stuff. But I don't know. I kind of think at this point, psilocybin is really the best one that we've stumbled on. Given enough time, the field may evolve. For 50 years, nothing is done. That's such a shame that politics have destroyed the field where millions of people were suffering and could have been really helped, we think. But once things start going, people start making other derivatives, and maybe they'll get approved in clinical trials with different substances. Sheldon and I made a bunch of phenethylamines, and there are a bunch of tryptamines out there. There may be some that are, better for particular things. So as time goes on, we'll see that evolve like any field would normally evolve.
Yeah, I like to say science is young, and science gives us provisional truths that 2 years out might not be so true. And
and some of the things that they're doing now in this field they couldn't have done 50 years ago. Some of the functional magnetic resonance imaging, magnetoencephalography, those kinds of things they couldn't have done. And the mathematics for analyzing the data from brain imaging and magnetoencephalography or functional magnetic resonance imaging, the mathematical techniques and the computational power didn't exist to do that until in the last decade or so. So things are interesting and getting more interesting.
So possibly last question before I let you go. Around the patent on GMP psilocybin, there's an organization that has that patent. As a chemist, I hope I'm not wrong here, but would you imagine that there's other methods to make GMP psilocybin other than what is patented?
Yeah. When people were so upset about that patent, this patent, there's so many little workarounds. Mm-hmm. The patent basically describes a standard way to make psilocybin. And the only difference is if you were making it, you might use a different solvent, you might heat it for a different length of time, you might recrystallize it in a different way. But these are just trivial, minor modifications that don't affect the basic synthesis. So I kind of don't. Well, I never was worried about the patent keeping people out. There's this shtick that they've got a patent and nobody's going to be able to make psilocybin because they've got it all, and that's not true.
Right, exactly. I imagine that. Well, you probably saw the first ever venture capital fund for psychedelics came out of Canada recently, a couple weeks back.
Yeah.
I don't know any of those people on the list, which is really weird. But at least we've got one, and that means there's probably more coming. So I would imagine there's going to be competition for Compass and other for-profit groups soon.
Yeah, I don't know how much money there is actually to be made, because the cost of the psilocybin is trivial compared to the cost of the therapy.
Mm-hmm.
If you think a dose of psilocybin might cost $100, you could inflate it up like drug companies do, but it's not going to work if there's competition, because they're going to keep the price down. The cost is going to be the rent and overhead on the clinical space, and the clinicians and physicians you have to have there to sit with them. That's going to be the cost. Those guys making $150 an hour for 6 or 8 hours, and there's 2 of them, and having a doctor on call plus the rental of some clinical room. That's where the money is. And I don't know how you make money on something like that. I mean, you keep your cost as low as possible so that people can afford the treatment. So what's left over to pay off the venture capitalists? I don't know. I hope that these guys aren't expecting big payoffs, because I don't really see it.
Right. Absolutely. It's a really tricky thing. We've been looking at it for a long time, and it's just a complicated subject.
Well, another thing in the UK that's different, over here in the United States, corporations used to be set up for the benefit of their stakeholders, the consumers, the customers. And then it's switched over now. So in the US, corporations are just providing profit to the shareholders. The stakeholders be damned. It's the shareholders that count. In the UK, they still have to provide benefit to the stakeholders, not just the shareholders. So they have to provide a benefit. So they still, whereas over here, corporations just have run amok. These greedy capitalists just run amok to rip off people for as much money as they can. In the UK, they still have to do something for the stakeholders, not just the shareholders. So it'll be interesting to see how it plays out.
Yeah, that is really interesting. Yeah, cool. Well, we're coming up on time, but is there anything else you want to point out? Maybe how people can help out Heffter?
Well, they can go to the Heffter website, and we have a PayPal button they can click. Money is the choke point on almost everything we do. We have a proposal now that's been vetted. We peer review everything that we fund. We send it out to experts in the field and get the reviews, and then send back to investigators so they can refine it until it gets to where it's acceptable. So we didn't want to fund anything that's crap science, so we started doing that early on. So we have a proposal for treating eating disorders, which is the most lethal psychiatric disorder there is. It primarily kills young women, and there's no good treatment for it. So we have a protocol to do that. You're looking at several $100,000. The donors that we've been dependent on are pretty well tapped out. The things we're doing, the alcohol study is a $2 million study, and so we could certainly use another philanthropist who has big pockets. But go to the web page, and we have a place on there that tells you how to donate, and PayPal, or you can write to our business manager, write to the office. Tell us you want to give us $1 million. That would be great.
Absolutely. I know there's a few of them out there. I saw some VPs of big banks join our email list yesterday. So I'm like, okay, cool. Just stay tuned and donate, share the wealth. Like MAPS, there's never really enough money. MAPS has the lion's share of it. Dennis says that pretty often, and why not get some broader research going?
The thing that makes Heffter different, MAPS is trying to develop MDMA for PTSD. Compass is trying to develop psilocybin for treatment-resistant depression. And USONA is also developing psilocybin for depression. What Heffter does is try to find what are the other applications where the psilocybin-assisted therapy can work. Alcohol use disorder, nicotine addiction, obsessive-compulsive disorder, eating disorders. We're trying to find all the possibilities without the idea that we're going to develop these as drugs, so that when psilocybin is approved for one indication, that properly trained clinicians who have the credentials can use that treatment for other things. Because the FDA only lets you get approval for one indication. So right now it's for depression or treatment-resistant depression. So if you wanted to treat people with alcoholism, well, you're going to spend $30 million to go through all the rigmarole to get to that point. Whereas if we show that it works in a reasonably good, well-powered study, like the one that's going on at New York University, they could use it off-label, and that would the FDA doesn't like off-label stuff, but if we have a database showing that it works with these early indications, then people could be using it. So we're basically trying to find what are the possibilities rather than focusing on one indication and say, well, let's move this forward to making it a drug for that. But what are the things it could be used for? What are all the possibilities? So that's more what Heffter's doing than anybody else is doing.
I think that's huge. Very important. So thank you for keeping it that way, and very excited to see what happens. So
Me too.
Dr. David Nichols, thanks again for joining us, and everybody go check out Heffter. Very important work. And there you have it, Dr. David Nichols, an amazing psychedelic chemist, and I really hope if you're interested in chemistry, you might go after it. I think chemistry is very interesting, and for a number of reasons, we need lots of chemists. So please dig in if it's of interest. And what'd you think? Let us know. You can leave a review of the show on iTunes or Stitcher. You can join us on the Facebook group, Psychedelics Today group on Facebook, and have a conversation with us, or let us know on any of the socials. We're on Instagram, Twitter as well. So please do let us know what you think. We would love to chat with you. Coming up, we don't really have a clear timeline of what's going on. We've got some classes we're launching in the fall. You can check that out at psychedelicstoday.com and under online courses. And other than that, we're trying to figure out our schedule. Kyle and I are really hoping to do some breathwork workshops. We're looking to be in Vermont for our own kind of 5-day retreat we're doing with our teachers in the next couple months, and that's going to be amazing. More things happening at dreamshadow.com if you want to learn more about that. And that's about it. So hope you have a great rest of your day, and see you on the other side. This is Joe Moore signing off from Psychedelics Today in Breckenridge, Colorado. Bye.